later. That's what we've been tracking real time
We
and
are
what
live,
the crew is using right
watching the
now to
moon.
keep up with their next
But
milestones.
I'm going to step off for a second and come right back. I'm going to take a shower in a little bit, and they're going to go into complete darkness right now. So I'm turning this off and the mic, and I'll be back.
Integrity Houston, 10 minutes till the LOS. We'll take a snappy sit rep from the cabin if you have one.
Okay, Jenny, that came, we missed most of that, but just a 10-minute warning, is that what you're saying?
10-minute warning for the LOS, and I'll take a quick sit rep from the cabin, please.
All right, cabin is still full of excitement. We've got Christina in window 2, Ike in Victor in window 3. Reed's actually been trying to get some images out of the docking tunnel. We can see the Earth and the Moon and part of the Moon out of the docking tunnel, which is pretty good. And I'm just grabbing some footage right now with our interior cameras.
Copy, Jeremy. We'd like to know what camera Reed is using and also the status of window 1. Looks like there might be a shroud removed.
Okay. Reed was using the Z9, and the T-shirt shroud is still on window 1, but we took the camera out of it. So maybe that's what you're noticing. But when I looked in there, I saw a lot of sunlight reflecting around.
Copy. That makes a lot of sense to us, Jeremy. I want to remind you, coming up on this LOS, that we'll take sit reps in the blind. And as more and more of the moon is in darkness, we will take any report you have on impact flashes.
All right, Jenny, you have to say again your last. There's a lot of conversation here, and I was on the other side of the cabin, so I missed all of it.
Look out for impact flashes, and we'll take sit reps in the blind.
Okay, impact flashes, sit reps in the blind. We got it. And yeah, just so you understand what's going on with window 1, there is light coming through the outer hall from window 2 into the inside of window 1, if that makes sense. Like I can see the inside of the vehicle when I look between the 2 panes of glass.
Copy.
You're getting your first live look at Orion, the Moon, and the Earth. Everyone in this picture. This is a live view from the Orion spacecraft. Currently aboard Orion, 4 crew members, Reed Wiseman, Victor Glover, Christina Cook, and Jeremy Hansen. And on the Earth, all of us, all of humanity. You can see the moon is starting to get a little bit dimmer as the astronauts are going to pass behind it. Now 6 minutes and 26 seconds away from that loss of signal. Again, we will be out of communication with them for about 40 minutes until they come around the other side of the moon and we can re-establish contact.
Integrity Houston, you are 6 minutes from your 40-minute Lunar Flyby LOS. From all of us, it's a privilege to witness you carrying the fire past our farthest reach. Thank you. Godspeed.
Thank you for that, Jenny. And thank you to all of you for allowing us the immense privilege to be on this journey together. It's quite amazing. And as we go on this journey, thinking about the NASA mission to explore the unknown in air and space, to innovate for the benefit of humanity, and to inspire the world through discovery. And as you've gone along on this journey with us, hopefully we're doing just those things. And as we get close to the nearest point to the moon and farthest point from Earth, as we continue to unlock the mysteries of the cosmos, I would like to remind you of one of the most important mysteries there on Earth, and that's love. Christ said in response to what was the greatest command, that it was to love God with all that you are. And he also, being a great teacher, said the second is equal to it, and that is to love your neighbor as yourself. And so, as we prepare to go out of radio communication, we're still going to feel your love from Earth, and to all of you down there on Earth and around Earth, we love you from the moon.
Houston copies. We'll see you on the other side.
We will see you on the other side.
Poignant words from NASA astronaut Victor Glover, and a little bit of a love letter from the other side of the moon all the way to Earth. Glover touching on the teachings of Jesus, including to love your neighbor as yourself. We are now less than 3 minutes away from loss of signal with the Orion astronauts. The Artemis 2 crew will be out of signal for about 40 minutes as they are on the other side of the moon, continuing their work photographing the lunar surface, and they will reemerge, and we will also get this view on the other side. Just about a minute and a half now until we lose communication with the astronauts aboard Orion on the Artemis 2 mission. Now, 5 days and 6 minutes since their launch on April 1st. Again, we'll be out of communication for about 40 minutes. And this really beautiful view of a crescent moon and a crescent Earth. How great thou art. "30 seconds now until we expect loss of signal. And we have confirmation of loss of signal of the Orion spacecraft as it flies behind the moon. We expect to regain communications with them in another approximately 40 minutes. This was expected as their spacecraft is now out of direct line of sight with Earth and behind the moon. And this is a poignant moment as it's the first time in over 50 years that we have humans completely unreachable by anyone else on Earth. No matter how distant or secluded, we could reach anyone living on Earth, but while the crew flies behind the moon, it's simply impossible to make contact with them. This is a live view inside the Science Evaluation Room here at Johnson Space Center and just down the hall from Mission Control. This team has been monitoring the flyby all day as the team has continued capturing targets on the lunar surface. We even got to see this team in action as they were helping the astronauts identify some of the features they were seeing on the moon but not expecting. There will be a couple of milestones during this loss of signal. The first will be when the astronauts make their closest approach of the moon at MET 5 days, 25 minutes, and 34 seconds, when we expect they'll be 4,067 statute miles above the lunar surface. Their maximum Earth altitude will be reached just 2 minutes later at 5 days, 27 minutes, and 39 seconds, when their altitude should be approximately 252,756 statute miles. Once those milestones are reached and we have confirmation, we will report the official numbers. Throughout the Artemis 2 mission, astronaut voice, images, video, and vital mission data must traverse thousands of miles, carried on signals from NASA's powerful communications systems, the Near Space Network and the Deep Space Network. Let's learn a little bit more.
NASA's Artemis 2 will send 4 astronauts around the moon, preparing humanity for a long-term lunar presence and future journeys to Mars. Enabling communication and navigation for this test flight are NASA's Near Space Network and Deep Space Network. With antennas around the world and a fleet of relay satellites, the networks will deliver vital data to and from Earth through all phases of the mission. The networks are seamlessly integrated at NASA's Johnson Space Center in Houston, Texas, where Mission Control coordinates the network handovers. These transfers represent a delicate dance between the two networks, exchanging support as the mission shoots toward the moon. On the launch pad and during their early orbit phases, NASA's Orion spacecraft and Space Launch System rocket will rely on communications and tracking services from the Near Space Network. After its translunar injection burn, the Deep Space Network's global array of antennas will serve as Orion's primary communication support during lunar orbit. As the mission journeys farther into space and away from Earth, signal strength weakens and bandwidth is conserved for crew communications. The astronauts will have a near constant connection to Earth, ensuring their safety on a journey farther into space than ever before. We say near constant because as Orion goes behind the moon, a planned loss in communications will occur. The Deep Space Network will be standing by to reacquire the signal as Orion reappears. The Artemis II mission also provides an opportunity to test new capabilities. Using laser links, NASA will periodically transmit Orion data to showcase the benefits laser communications could have for future human spaceflight missions. The data from Orion, sent by radio signals or laser links, is massive. The mission is gathering images, data, and video, while also generating details about mission health and crew voice files. All of that data gets processed here on Earth, where systems compress it for efficiency. In the future, we'll upgrade these systems on Earth so that image and video clarity improve with each moon mission. With the Artemis II test flight, we're evaluating the communications infrastructure that will help carry us into the future as we explore the moon and journey forward to Mars.
We are now about 33 minutes until we expect to regain communications with the astronauts aboard Orion. And in the meantime, I've got Dr. Kelsey Young, Artemis Science Flight Operations Lead, here with us. Thanks for joining me, Kelsey.
Thanks for having me. This is such an exciting day.
Oh, no kidding. It has been so cool to hear you communicating directly with the crew. And I know that you have been preparing for this for years, so I am so excited for you and for your team. So just to get into that background a little bit, tell me about your background and what you've been doing on console.
My background is as a field geologist. Actually, I studied impact cratering in the field for my PhD, so all these descriptions of impact craters have me just absolutely swooning. How I got into this, though, is, during my PhD, I got an internship at NASA and ultimately never left to integrate science into flight operations. So we developed the Science Officer Console, for which this is the first mission we're supporting. We developed the Science Evaluation Room that's right upstairs, and so it's so gratifying to see this operation structure come to fruition, especially on a day like today.
I would have to imagine so. And we've got a great view of the Science Evaluation Room right now. Is there anything that has stood out to your team so far?
Absolutely. So as you might have heard in some of the press briefings and content that, we've been putting out, color and albedo were really exciting targets for us. We've heard several amazing color descriptions so far. Just to highlight maybe one of them, we heard about greenish and brownish hues near Aristarchus, which is actually a feature that we can see here from the near side. And those greenish hues could actually tell us something about the volcanic evolution of that area. So you can bet that the science team is going to be prioritizing downlinking those images and the crew audio that we didn't hear that went into those recordings to learn a little bit more.
Wow, that is fascinating. I was hearing those colors and very interested just from a personal standpoint because looking at the moon from, 250,000 miles away, we don't see green or brown. So just hearing that them being so close and getting to see that, fascinating, and I know very exciting for you. So what are you expecting to see in the upcoming portion of the flyby?
The upcoming portion is actually going to be really exciting. So right now, as we speak, while folks in the room are kind of taking their their stretch breaks and everything, the crew are still hard at work. They still have targets to image and describe during this LOS. But when we come out, the first thing, of course, we're going to hear about is Earthrise. We're really looking forward to hearing about the crew's experience with something that we can connect with, and that Apollo 8 brought us such amazing images from. But then we start to get into describing the Terminator, as well as looking for things like lofted dust, which tell us about the modern lunar environment. Then the vehicle's going to orient away from the moon for an hour and then pivot back for the eclipse observations, which is a whole different set of science observations that we're really looking forward to.
It's kind of nice that the crew will get a little break in there because they have been hitting it hard today with photos and videos and annotations. What are you hoping that the crew sees coming up? Is it that lunar dust?
Oh my goodness, that's a hard question to answer. I mean, we've already gotten such great descriptions. I mean, the Terminator seems to just be like one of their favorite things to look at and describe. So I feel like, that was something we were looking forward to. I feel like we've really gotten some great descriptions. So absolutely, I'm looking to the human moment of Earthrise. Lofted dust is an exciting one, and lofted dust will be a target for them in the right around the time of Earthrise, but again in the eclipse period. So I'm really looking forward to seeing. I mean, they've already highlighted just in the course of their flyby so far how the moon has changed, and this is going to be even more dramatic change to go from their end of this kind of lunar illuminated piece of the flyby into the eclipse time frame. And I can tell you they're going to be experiencing a very different moon during that time, and I can't wait to hear what their observations are.
Yeah, that's absolutely fascinating, and what a privilege that we get to do that on this mission, because that's not always the case. If we had launched on a different day other than April 1st or 2nd, we wouldn't have gotten to see that eclipse. Is that right?
That's correct. April 1st and 2nd. I will say, I was asked a lot in the weeks leading up to the launch, well, what's your favorite day? And my answer truly was, there is no bad day to launch to the moon. We were going to get great science out of it no matter what, but it's a really neat opportunity to, bring the sun into the picture, bring different planetary bodies into the picture while still literally keeping the moon in center stage.
Fascinating. So what differences are we looking for at each site? We're hearing a lot of different terms. We're looking at craters. We're looking at mare. What are the differences that you're hoping to see?
We do have, as you highlight, kind of different prompts for each target. That's what they're looking at in their lunar targeting plan, which I know you've been showing. And we have even different prompts for the person with the really long lens on the camera versus the people with the unaided eye. And you've heard the crew talk about, oh my goodness, when I go from one to the other, I can really detect different nuances. And that's something that we experienced in simulations, but hearing them actually, see it for real has been really gratifying. But we're looking for different things based on the target. Sometimes we're looking for color. Sometimes we're looking for texture. For the Terminator, we're looking at kind of what texture and morphologies pop out to you and what kind of diversity you see along the Terminator. You've heard, Victor especially make some comments about future impacts for exploration. So already I think that their descriptions in this first part of the flyby have told us something scientifically, but also about future surface missions.
Well, it was so interesting to hear Victor talking about he was imagining in his mind's eye being down on the surface and walking around. That was very cool to hear. And when we're thinking about targets, I know some of them are determined based on the launch day because that determines the lunar illumination. So the ones that we're looking at today, how and why were these selected?
Such a wonderful question. This really gets at at the heart of some of our really highest priority science questions. Illumination conditions is a big one, right? So of course we need the targets that we're interested on the lunar feature to be illuminated by the sun in order to view them, but the timing in which they see them during the flyby enables us to ask different questions. So you heard in the pre-flyby crew conference talking about, well, the same pair, Reed and Jeremy, will get to actually look at Glushko crater twice, and that looking at it from different illumination angles allows us to understand that feature better and connect color and albedo with topography and morphology. Then you have other craters where you want to look at it with the sun shining on it obliquely versus straight on, and that tells you something different about the scientific objective that drove the target being on the targeting plan in the first place.
We've talked a little bit with the viewers today about what the crew is able to capture in this short time frame of those craters in different lighting conditions. Could take years for something robotic to be able to do based on attitude maneuvers and where the sun is at. So can you just talk a little bit about the importance of having both the robotic operation and having the crew?
Absolutely. We definitely don't want to minimize the impact of orbiting spacecraft. Lunar Reconnaissance Orbiter is the one that's often referenced. Data from LRO and its payloads have really been instrumental in getting us, frankly, to this point for Artemis 2 and future missions. But the human experience, the crew observations that we've already been hearing about, it is such a perfect complement to the orbiting spacecraft data because they are able to have this unique perspective. They are far enough away where they can make these contextual observations. You've already heard it. How many times have we heard the crew and their science sit reps say, if I track this feature from all the way up here in the northern hemisphere down to the southern hemisphere, here are comparisons I can make. That right there is not something we had the ability to do with the Apollo missions, and it allows just literally in the blink of an eye to synthesize observations that it would take, a really significant effort to coordinate with different orbiting platforms, and they're making it like that.
Wow. It has been very, very exciting to hear all of their calls so far. And so I've heard they were able to capture every single target so far too. Is that correct?
I think that's correct. And I think it's important also to remember that, and I know the science team is anxiously awaiting this, we've been hearing from the crew members who are not at the forward windows, right? Those crew who are, really in the thick of the observations, they are recording minutes-long observations per target on their crew tablets. We will be getting those down starting here in a couple hours, and that's going to contain really meaty science information that we haven't heard live yet, and that's going to form the basis of my conversation with them tomorrow morning, where we're going to have a really deep dive into the science and absolutely nerd out about what they were able to do today. One of the most gratifying things for me today is hearing multiple crew members say, thank you for putting the discussion times in the targeting plan, because when we have had the ability to put multiple brains on a problem, we have elevated each other. And I'm looking forward to them, sleeping on it overnight and then us actually being able to really, truly have an elevated science discourse tomorrow.
Well, we're looking forward to it too, and I cannot wait to hear everything that you guys get to learn overnight from some of those audio recordings and just everything that they'll be able to share tomorrow. So, Kelsey, I know you are very busy. You've done a great job today, and thank you so much for joining us for this interview.
Thanks for having me. It's such an exciting day.
We are now expecting acquisition of signal in about 24 minutes. As a reminder, the Orion spacecraft has flown around the other side of the moon, where they are out of contact with our deep space network.
Coming back very shortly. Alright, I'm pretty much back. Forgot to jack up the microphone. I'm pretty much back right now.
And we just heard confirmation here in Mission Control Houston that we have reached the closest point of our destination to the moon at MET 5 days, 25 minutes, and 34 seconds, and we anticipate the spacecraft's altitude is approximately 4,067 statute miles above the moon.
Yeah, so I ran this last night while I slept. Woke up this morning, said, okay, heading to work, turned it off, came straight back.
We're continuing to track what the crew is doing while around the other side of the moon. They are continuing to take pictures of the Earth, of the moon, the Earth now out of sight. What they're in right now is a crew choice event. The science team has encouraged them to find interesting features on the surface, to take photos of those, and describe why they were interesting. Something else that they'll be looking toward next, just momentarily, will be impact flashes. They've got a few minutes allotted to look at the darkest portions of the moon. They're interested in short-lived flashes on the lunar surface because these would be caused by impact bombardment. After their impact flash targeting, the team is interested in if the crew can see lofted lunar dust. This would only be visible just before Earthrise. Now 20 minutes until we expect to regain communications with integrity and the astronauts for Artemis 2.
Yeah, so then I came back, and first thing I did was jump on stream. I'll take my drops here. Those are gross. Vitamin B and some other cleansing stuff for...
We're live in Mission Control Houston at NASA's Johnson Space Center, but there's a team over 750 miles away also monitoring today's operations. And of course, just like us, they are in LOS, or loss of signal, with the spacecraft. This is LUCA, the Lunar Utilization Control Area, and it's joined by LISA, the Lander Engineering Support Area, which are twin control rooms that will support missions and operations in lunar orbit or on the moon's surface in real time at NASA's Marshall Space Flight Center in Huntsville, Alabama. The LUCA and LISA are right next to each other and just a short walk away from the SLS Engineering Support Center, which is used during launch, and the POIC, where science on the International Space Station is monitored. LUCA primarily supports Artemis science operations, while LISA will provide engineering support for landing astronauts on the moon. During this mission, Artemis 2, teams in the LUCA will use the facility to support first-of-its-kind science operations to better understand the deep space effects of microgravity and radiation on the crew's physiology, immune systems, and ability to complete various tasks. The data from these science operations will inform future crewed flights to the moon. For future crewed missions to the moon, members of the NASA Human Landing System Mission Insights Support Team, a group of engineers, safety leads, flight operations experts, and technical authorities, will work in the LISA. There, they will monitor lander systems in real time and be involved in key decision-making processes throughout the mission. Teams are using the LISA during Artemis 2 to observe mission operations and using the opportunity to inform and prepare for future crewed landings to the moon's surface.
Oof. That sounds crazy tasty. Not too bad though. Alright, what we got here?
We now expect to regain communications with the astronauts aboard Orion in about 17 minutes. In the meantime, a little overview of how our crew members flying by the lunar far side at an altitude of between 4,000 and 9,000 miles are testing the capabilities of the Orion capsule. Artemis 2 visualization lead Ernie Wright has simulated views of the flyby using detailed topographic maps of the lunar terrain and photorealistic lighting scenarios. The Artemis 2 crew members have been using these visualizations to prepare for this historic mission, which is paving the way for future exploration of the moon's surface and beyond.
So the most exciting thing to me about Artemis 2 is just the return to the moon. We haven't been there in 50 years. Human eyes are going to see parts of the moon that haven't been seen by anyone before. It also recommits us to exploring the solar system in a way that we haven't in a long time. And I think it provides an opportunity for younger generations to understand the excitement of doing that kind of exploration.
People just spamming
Artemis
flags.
is our return to the moon after 50 years. The emphasis of Artemis is going to be, first of all, science, but second of all, learning to sustain a presence on another world. First on the moon, but we're hoping that that's a stepping stone to Mars and other destinations in the solar system eventually. Artemis 2 will be a flyby mission. It's not going to land. We're testing all of the technology that we've created for flying to the moon since Apollo. A lot of systems have been modernized, and we need to make sure that all of those work. The astronauts will be looking out the window at parts of the moon that have never been seen by human eyes before. They will be flying by the moon at an altitude that's much higher than Apollo's orbits. And so they will see the entire disk of the moon, including areas that are closer to both the North and South Pole that astronauts from Apollo never saw. All of that depends on the lighting, which we really won't know until launch day, but we can practice with different lighting scenarios. It's hard for people to sort of picture that in their mind. If you can make a visualization of it, show them a movie, that helps everybody choose the targets and also practice aiming at those targets. The astronauts have actually been looking at these visualizations through the lens of the camera and practicing aiming at the various targets. This is a map of the surface of the moon, obviously, but it shows what the Apollo astronauts could see in sunlight while they were in orbit. The brighter parts are the parts that they could see. The darker parts, like this entire area here and places that are farther north and south, are places that they couldn't see in sunlight, either because it was nighttime there or because it was beyond the horizon of the astronauts. All of the Apollo flights orbited the moon at a distance of about 110 kilometers. Because the astronauts were flying at such a low altitude, their horizon was actually quite close, and they couldn't see the North and South poles. And this whole area over here was not in sunlight at the time. And it includes this amazing impact feature here called Orion. Orion is a very large impact feature. It's about 650 kilometers wide. It's got multiple rings. These are rings that form like ripples in a pond from the impact, but of course it's on a huge scale. The middle of Orion has that sort of dark basalt lava covering it, like the dark spots that we see on the near side. It's one of the biggest ones that's more on the far side than the near. So seeing it with human eyes and sort of picking out features that maybe you don't even see in robotic cameras is an important goal for the mission.
This Terminator that they're talking about is really cool too. I can imagine what that makes. It makes everything pop 3D.
This live view in the Science Evaluation Room, or the SIR, here at Johnson Space Center in Houston, Texas, just down the hall from where we're at in the Artemis Mission Control Room. Teams continuing to monitor the flyby.
Their teams are monitoring, and I'm monitoring the teams.
The crew continues their observations of the moon, even though they are out of touch with Earth. We expect to hear from them in 12 minutes and 26 seconds. Again, this is approximately 40 minutes loss of signal while they are out of reach of the deep space network. Right now, they are imaging or attempting to image lofted lunar dust. Throughout our coverage, we've talked a lot about the science and engineering behind today's lunar flyby, but we also spoke to the crew about what the moon means to them and how they see its place in human history.
Oh, the audio.
I remember being a little kid lying in bed at night and just looking out at the moon and whatever phase it was in, I was thinking, man, my friends that live like 20 miles away, they can probably look out and see that same exact moon. And then when I was in the Navy and I would look out at the moon and I'd be halfway around the planet, I would think, man, my brother can see that moon where he is and he's halfway around the planet from where I am. And it's a connection of life on Earth. We can all look up and see that moon.
It represents history. It is a witness plate. Everything that's ever happened to the moon is still written on the moon. There's no processes of wind or change in the Earth, geologic processes like we have here that change it. And something that's been telling and can read out the story of its own evolution, there's something beautiful about that.
I've also learned from my indigenous mentors that they refer to the moon as grandmother moon. So you've probably heard of Mother Earth. They use grandmother moon because grandmother moon is responsible for the water in their community. The grandmothers, sort of protect the water source, just like the moon moves the water around the planet, affects the tides. It's something that represents something different for each individual culture around the planet, and that's really neat because we all share that same moon in the night sky.
We all have seen the same side of the moon in different lighting conditions our whole lives. And so it seems very familiar to us, but it's also kind of unknown. When we get up close, some of the imagery that we'll get to describe and to share with people will be very unique. And that nature, both of those things being true about this one entity that we all know, just is really special.
It's just the epitome of a symbol of both something that's in each of our hearts, but that's also represents exploration and reaching.
You're looking at a live view inside Artemis Mission Control here at Johnson Space Center in Houston, Texas. We are currently out of contact with the Artemis 2 crew. This was a planned, or not really a planned, but a tracked loss of signal that occurs when the crew flies behind the moon. We use the Deep Space Network to communicate with the crew, and when they are behind the moon, they are out of reach of that Deep Space Network. And when you consider our nonstop communications during the time in which we live, this is even more striking. For the Artemis 2 crew, they're only currently communicating with each other. Now, we expect to regain those communications in under 9 minutes from now, and we also are hopeful for a view of Earthrise. Despite being out of communication, the crew is continuously capturing imagery of their predetermined lunar targets.
Crazy.
Now about 7 minutes, 25 seconds until we anticipate regaining communications with the Artemis 2 crew aboard Orion. In the meantime, Artemis 2 Lunar Science Deputy Lead Marie Henderson is training trained these astronauts to capture and document their views of the lunar surface for all of us to enjoy back here on Earth.
I cannot wait to hear their voices when they get to the far side of the moon and I can hear them talk about seeing the moon out their window. I try to imagine it now and I tear up thinking about it. Ooh, now I gotta hold on a second.
Gonna be right back.
We have human eyeballs connected to wonderfully smart brains our astronaut friends have. They are going to be able to observe the moon in multiple different ways. They can use their eyes, they'll look through their camera and snap pictures, and just looking out the window getting that human experience. But during Apollo, the astronauts were so much closer to the lunar surface. Our astronauts are going to be doing a flyby at a higher altitude, so they're going to be able to see the whole moon as a lunar disk on the lunar far side. That's a brand new, unique perspective that humans haven't been able to look at before. We are doing a lot of lunar geography training with them. They have study sessions and quizzes they can do that are assigned to them. You know, even if you're an astronaut, you still get homework. We actually get in the mock-up. In that enclosed physical space, we have to think through the hardware that they have, the cameras, the computers, their microphones to make these observations. There's 4 windows up front. Through one of those windows, one of our astronauts will be using a Nikon D5 camera with an 80 to 400 millimeter lens. So something that allows them to zoom in really far and actually take more detailed observations of the surface. It's almost like looking through a pair of binoculars as well. It's just like being a geologist out in the field. They're telling us what they're seeing, looking for colors, textures, different morphologies, and comparing the region that we're having them look at to the regions that are around them. We have a science team that is planning the targets that are going to be observed, putting them all on the timeline of how they're going to be observed, and then taking the first look at the data when it comes down. The Apollo astronauts were only on the moon for 300 hours total, and they only went to the equator. That's like going to places that were safer landing sites, and they only saw so little, 300 hours total. And so we have so much more to explore and so much more to learn. And we are the beginning of the next generation that gets to start being a part of these discoveries.
We are now 4 minutes and 28 seconds until we expect to regain communications with the astronauts flying aboard Orion on the Artemis 2 mission. They are now flying behind the moon. While behind the moon at an MET, or mission elapsed time, of 5 days, 25 minutes, and 34 seconds, we expect this was the point in which they made their closest approach, 4,067 statute miles above the lunar surface.
Back again. What'd I miss? What'd I miss, Artemis? Oh, man. Some people like to type on laptops. I dislike that a lot.
We're live in the Artemis Mission Control Room in Houston, but we are not the only room monitoring today's flyby. As you can see, this is the SIR, the Science Evaluation Room. It's in the same building and just down the hall. It's a multidisciplinary science team supporting the Artemis 2 crew in real time, including experts in lunar geology, impact cratering, volcanism, polar science, imaging, and visualization. You can see the SIR here. That's the Science Evaluation Room. It's embedded within Mission Control to provide science input during live operations like what we see today. But additionally, the Science Mission Operations Room is a back room that processes data, evaluates imagery, and supports rapid analysis. We also have our science officer, Kelsey Young, here on console today. She's serving as the primary interface between the science team and the flight controllers, ensuring science priorities are represented during mission execution.
Sir.
Coming up on 1 minute and 36 seconds until we contact Orion. Meanwhile, aboard the spacecraft, the crew has continued executing their lunar flyby tasks. As we discussed earlier today, these activities have been precisely timelined, and this is the fourth of 5 blocks of time during which the crew will be observing the moon from Orion's windows. At this time, pilot Victor Glover and mission specialist Christina Cook are observing the moon at windows 2 and 3. One crew member is in window 2 with a blue shroud over the window, taking photos and using an 80 to 400 millimeter zoom lens, while the other astronaut is in window 3 using their portable computing device, also known as a PCD, to make annotations. And both of those crew members are making audio recordings of what they are seeing. They are wearing headsets connected to their PCDs, and those audio recordings are being sent to the science team tonight. We are not hearing those live. However, we have been hearing quite a lot of great descriptions from the crew who have been serving as the support. Right now, the support team members are Reed Wiseman and Jeremy Hansen. Those team members are providing science sit reps, situation reports, calling down a few times each hour to discuss what they're observing. And even though we're out of contact with them right now, they are still conducting those science sit reps as they'll be available once they come back around the moon. The situation reports include how the crew is positioned, any missed targets, or anything unexpected they saw. They're also including lunar target descriptions, any hardware issues, and their emotions and reactions. Again, we are standing by to acquire signal from the Orion spacecraft.
Where y'all at? Oh, they're clapping. Ah, blue screen of death. Ah, we're back. Oh, we're gone. Ah, we're back. Oh, we're gone. Ah, we're back. Oh, no. Oh, wait, no, that's not them. I think they see it up there. Oh. I'm watching the reflections up here on the windows. It's like they're having issues too. Gone. Back. Gone. Back. Gone back. Alright, I think we're steady. Nope.
We're in the Artemis Mission Control Room at Johnson Space Center, getting our preliminary contact with Orion, that acquisition of signal coming after a 40-minute loss of signal, during which the crew was flying behind the moon, out of contact with anyone on Earth. We are getting our first views from Orion after the loss of signal. Orion has come back around the other side of the moon, and that little crescent that you see is Earth, over 252,000 miles away. With this transit complete, Lunar Flyby continues, but Orion has also technically begun its journey home.
Yeah, we're past halfway.
Right now, the crew are getting a few moments to enjoy and take photos of Earthrise for themselves, and we expect to contact them shortly. But we do have good signal coming from Orion. This view from inside the Orion spacecraft, all 4 astronauts now back on the other side of the moon and in contact with us on Earth. Their tasks for Lunar Flyby did not stop as they went behind the moon and out of contact with us. We anticipate during that time they were attempting to image some impact flashes, short-lived flashes on the lunar surface, which would be caused by impact bombardment and potentially even lofted lunar dust. Right now, of course, they are getting pictures of Earthrise. After this target, they will get a short observation break. It's about an hour long, actually.
Houston, integrity, comm check.
Integrity, we have you loud and clear. Homie.
Homie.
Houston, we have you the same, and it is so great to hear from Earth again. To Asia, Africa, and Oceania, we are looking back at you. We hear you can look up and see the moon right now. We see you too. When we burned this burn towards the moon, I said that we do not leave Earth, but we choose it. And that is true. We will explore, we will build ships, we will visit again. We will construct science outposts, we will drive rovers, we will do radio astronomy, we will found companies, we will bolster industry, we will inspire. But ultimately, we will always choose Earth. We will always choose each other.
I really hope this brings people together.
Integrity from Earth, our single system, fragile and interconnected. We copy. Those of us that can are looking back.
We are happy to say we copy.
It must be uncomfortable being in those khakis and polos tucked in like that.
Those first communications back with the astronauts aboard Orion. Christina Cook calling back to what she said just before translunar injection burn, that with this burn, we do not leave Earth, we choose it. The translunar injection burn served as not only what put them on this trajectory to fly around the moon, but what also committed them to splashing down in the Pacific Ocean on flight day 10. At this time, the crew is entering an observation break. We expect this to last about an hour, and it's probably a welcomed break following their very, very busy day taking pictures making annotations, making audio recordings, and communicating all of the wonderful things that they are seeing on the moon. This observation break is also partially due to the fact that we will be entering an eclipse later. This will be the first solar eclipse that humans have seen from the moon. The astronauts will need to wear eclipse glasses for the first 2 minutes until the sun is completely covered by the moon, and then they have additional targets that the science team is hoping that they will photograph. We will have communications with them during that eclipse time frame. Because of that eclipse, Orion's attitude must be changed right now so that its solar arrays are in the sun. This will help it charge the batteries needed to power it through that eclipse time frame. This view on your screen is a visualization. The spacecraft now 4,224 miles away from the moon, and that number will now continue to grow, while the number of distance from Earth, 252,699 miles, will continue to shrink all the way until our crew is back home.
Slowed down quite a bit. 925. Gonna open up live real quick.
Again, we are MET, mission elapsed time, 5 days and 58 minutes since the launch of Artemis 2. We have reestablished communications with the crew and the Orion spacecraft, now entering a little bit of a break while they are out of visibility, or the moon is out of their visibility. The spacecraft will be reoriented to view the moon ahead of an upcoming eclipse. This current attitude maneuver helps charge the solar arrays and batteries aboard Orion that will power them through the eclipse. So, I guess we're gonna wait for the eclipse. I'm gonna jump off real quick.
Integrity, Houston. In mission control, all of your flight controllers and your flight director have flipped their Artemis 2 patches around. We are earthbound and ready to bring you home.
Who's gonna talk? Well, they were like, nope, we're staying.
That's great. Great to see the light of day as we head back to sea.
I guess the comm dropped out. I'm gonna start setting up a new stream too for the Audio Play YouTube. I was surprised by a short that I put out this morning of last night's stream, how good the audio sounds. You know, playing stuff from Ableton. Alright, going to drop off for a second, let them get this figured out. We might come on a little bit later tonight. And who knows, whether it's Destiny, Diablo, more space, Ableton. Who knows? Maybe I won't even come on. I don't know. That was crazy.